Hello students and welcome to Unit 3 Lesson 3. In this lesson we will learn and practice substituting values to evaluate algebraic expressions. We will specifically be looking at how can we substitute values to figure out volume of three-dimensional figures, but this can be applied in many circumstances. Our essential questions for today are: what is substitution? 2. How can I substitute values into an algebraic expression? And third, how can I use the order of operations to evaluate algebraic expressions? And you can only do so when you use substitution. So to begin, let's get a definition of what substitution is. Substitution is to replace a variable with an equivalent value, often a constant. So if you think about substitution in relation to basketball, that's to exchange one player for the other. Substitution in math is similar. You're going to replace the variable with a constant. Notice, if you replace variables with constants, you're also going to be changing from an algebraic to a numeric expression. Once replaced with a constant, the order of operations can be used to simplify the expression because it is no longer algebraic, it is numeric. So for example, remember in lesson 1 when we said Cohen is 5 inches shorter than Adelie? And we wrote that Cohen's height is a minus 5? Well, if we knew that Adelie is 36 inches, we can then substitute 36 for A because they are equal in value. A is standing for this amount. So we could use that to figure out what Cohen's height is. Instead of writing A minus 5, we can substitute 36 for A and write 36 minus 5. This changes the expression from algebraic to numeric, and then it can be simplified using order of operations to get 31 inches. Cohen is 31 inches tall. You also used substitution in our Pythagorean theorem lesson, not only when you used a squared plus b squared equals c squared, but also when you used the formulas for area. So for instance, we did this problem where you had to figure out the area of this triangle, and you did so using area equals 1/2 base times height. And when you did that, you substituted the base length, which was 8, for the letter B, and you substituted what we got for A for the height. You used substitution many times in the past, but now you have a name for it. Substitution is a very big part of formulas. Substitution and formulas together can help you solve area, surface area, and volume problems. Attached to your guided notes for this lesson is a copy of this year's 8th grade PSSA formula. Here is an example of a formula sheet, and you can see that on this formula sheet there are 3 3D figures that you are responsible for knowing how to calculate. So let's use that formula sheet to help us figure out a few real-world examples. Sorry about that. Here's our first example. A clown wants to fill his party hat with confetti. Use the drawing at the right, this picture here, to determine how much confetti his hat will hold. Well, if you think about the shape of this hat, it is a cone. Now, look on your formula sheet attached to your guided notes and find the formula for the volume of a cone. If you look, you will find that the volume of a cone is 1/3 times pi times the radius squared times the height. Now, if you look at the two variables, we have radius and height. This problem does not explicitly give us the radius. Instead, it gives us the diameter, but the radius is half of the diameter, so our radius is 4 inches. It explicitly gives us the height, which is 6. We'll label that H to remind us. Now we're going to substitute the values. That means to put them in place of. So volume equals 1/3 times pi, which we know is 3.14, times the radius, which is 4, squared, times the height, which is 6. Now, We have four operations: multiply, multiply, exponent, and multiply. We know that we must do exponents first because of the order of operations. So we get 1/3 times 3.14 times 4 squared, which is 16, times 6. Now, because this is all multiplication, we do not have to go left or right. The commutative property says we can solve this in any order. So let's save the fraction for last. Let's do 3.14 times 16. So we have 3.14 times 16, which is 50.24. So now we have 1/3 times 50.24 times 6. Again, we're going to save this fraction multiplication for last. So we get 50.24 times 6, which is 301.44. So we need to take 1/3 times 301.44. Now remember, any number that does not have a denominator written has a denominator of 1. So we multiply straight across, we get 301.44 over 3, which is really division. So take 301.44 divided by 3, and we get 100.48. So the volume of this party hat is 100.48 cubic inches. And you could restate as the answer. The clown will need 100.48 cubic inches of confetti to fill his hat. Let's do another example. A large tank at a local business is pictured to the right. How many cubic feet, now it doesn't explicitly say volume, but we know that cubic units is fill or volume. How many cubic feet of oil will fit in the tank? Now there's a second question. How many gallons is this if there are approximately 7.5 gallons in 1 foot? So our first task is to figure out how many cubic feet of oil will fit in this tank. To do so, we will need our volume formula for a cylinder. So look on your formula sheet and find the formula for volume of a cylinder. Volume of a cylinder is calculated by pi times the radius squared times height. And in this problem, it tells us the radius and it tells us the height. So we just need to substitute those values. So volume equals 3.14 times the radius, which is 6 squared, times the height, which is 8. We have multiplication, exponent, multiplication, so we have to do exponent first. So the volume is equal to 3.14 times 36 times 8. Now we can just multiply this and we'll get our answer. So we have 3.14 times 36, which is 113.04 times 8. So we times that by 8 to get our final answer of 904.32 cubic feet. Now, this only answers the first half of our problem. The second half is asking us how many gallons this would be. Sorry for the interruption, students. I couldn't hit the pause button in time. So what we're looking for is how many gallons would be in this amount of cubic feet. Well, we know that there's 7.5 gallons in each cubic foot, meaning 1 cubic foot. And we have 904.32 cubic feet. So we have 904.32 times as many as 1. So if we multiply 7.5 times 904.32, that will tell us how many gallons is equal to 904.32 cubic feet. Now if we do that, 7.5 times 904.32, we get 6,782.4 gallons that will fit in this tank. So we could restate our answer. The tank will hold 6,782.4 gallons. Let's do one more example. A city's water tower has a tank in the shape of a giant basketball, which is a sphere. How much water does the tank hold when it is half full if it has a diameter of 20 feet? So we know that the diameter is 20, so across the center is 20 feet. Now, look at your formula sheet. We want to figure out the volume. We know that this is going to tell us the volume when it is full. At the end, we will have to figure out how much it is when it's half full. So the volume of a full sphere is 4/3 times pi times the radius cubed. Now remember, cube means to multiply by itself 3 times. Our problem does not explicitly tell us the radius, but it does tell us the diameter. And we know that the radius is half of that, so we know that the radius is 10. So we have 4/3 times 3.14 times 10 cubed. 10 cubed means 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. So we have 4/3 times 3.14 times 1,000. So if we do 3.14 times 1,000, we get 3,140. So we have to do 4/3 times 3,140, which we know has a denominator of 1. So if we multiply straight across, 4 times 3,140 is 12,560 over 3 times 1, which is 3. If we take that amount, divide it by 3, that tells us how many cubic feet of water the tank can hold. So we get 4,186 and we see that repeating decimal, we'll round it to the 7. That's how many cubic feet a full tank will hold. But we want to know how much it will hold when it is half full, so we'll divide that by 2. 4,186.7 divided by 2, and half full, this tank will hold 2,093.35 cubic feet of water.